thumbs up that you hear me and see the board okay? All right, cameras should be on. Lots of cameras are off. That's not a good thing. All right, guys, we are going to wrap up section 6.7 hopefully today. And then tomorrow we can use tomorrow to kind of, I'll probably let you guys work on the homework that I assigned today and then just let you wrap anything up and get ready for your quiz on Thursday because the quiz for this section is on Thursday, not Friday, so I can get those seniors' grades done. All right, so we are still working in section 6.7 on solving radical equations. So yesterday you saw that to undo a radical, we have to use a power or an exponent, right? Today's problems are going to look a little bit different, but we're going to treat them the exact same way. Today we're going to feel like the radical is missing, but it's really there, but in disguise. So guys, let me just practice a few things with you first to get ready for today's problems. When you have a rational or fractional exponent, we learned how to evaluate that by converting it to a radical with a root and a power. Because to times 16 by itself, 3/2 of a time, we can't do that. So we actually convert it by taking 16, putting it under a radical, and then the exponent is actually made up of a power over a root. So it is a root of 2 raised to a power of 3. And that's how we evaluate these rational exponents. So now we can say the square root of 16 is 4. 4 to the third power, 4 times 4 times 4. That gets us 64. So just remember that if you have a rational or fractional exponent, guys, that's actually a radical in disguise. So the problems that we work on today, they're not going to have radicals in the equation, but they're going to have these rational exponents, which we know are radicals in disguise. So we're still going to have to use exponents and powers to solve these equations today, even though it's going to look like they don't have a radical. All right? So now what's going to happen is we're going to have a power to a power. So we know that according to our exponent rule, when one exponent is raised to another exponent, you multiply your exponents together. So this will be x to the 2 times 3 we multiply is 6. So keep that in mind, that when you raise an exponent to another power, you have to multiply those exponents together. Right? Well, let's think about fractions. Same thing. If you have an exponent raised to another exponent, you have to multiply them as well. So we multiply straight across on top and straight across on bottom. So this becomes x to the 1 times 3 is 3 over 4 times 2 is 8, right? Okay, well, guys, we're going to want to get rid of this fractional exponent. Like, just like we wanted to get rid of those radicals, we're going to want to get rid of those fractional exponents as well. So watch what happens when you raise a rational exponent to another power, but that power is his reciprocal. 2 over 3, raise it to 3 over 2, and watch what happens. We know we have to multiply them together, so this will become x to the 2 times 3 on top is 6, over 3 times 2 on bottom is 6. 6 divided by 6 is 1, and x to the first, guys, is just x. So when you raise a rational exponent to his reciprocal power, it cancels out, and you're just left with the variable. So that's the technique we're going to use today. If we want to get rid of a rational exponent, which is like a radical in disguise, we're going to raise it to that reciprocal power, and that will make that exponent go away. All right? So just remember, rational or fractional exponents get rewritten as a radical with a root and a power. I showed you that. They get rewritten as radicals. Therefore, rational exponents are radicals in disguise. This is a radical problem in disguise. So we will still use exponents and powers to solve equations with these rational or fractional exponents, all right? Except we're going to always use that reciprocal power. All right, so the steps that I need you guys to follow today. The first thing I want you to do is get whatever the rational or fractional exponent, thank you, Marquita. All right, get whatever the rational or fractional exponent is on, get it alone. Get that alone, that part of the problem alone, on one side of the equal sign. Always do that first. Then you're going to raise both sides to a specific power. You're going to raise it to the reciprocal power of whatever exponent is there. And then you'll be able to solve for x. All right, let's look at the first example. So guys, if you look at example 1, you can see that there isn't a radical written in this equation, but you do have a fractional exponent, a rational exponent. That's a radical in disguise. So we don't have to rewrite it as the radical, but we can still use that power to undo it. All right, so the first thing I need you to do is realize that this power of 1/3, it's only on the x. So I need you to get x to the 1/3 completely by itself. I need this 3 and I need this -5 to go to the other side. Whatever that fractional exponent is on, I need you to get it alone. And since it's only on the x, I need you to get x by itself. So we're going to move the 5 away just like normal. Let's add 5 to the other side. And now we're going to get 3 times x to the 1/3 equals 15. Well, still, I need this x to the 1/3 alone. That 1/3 is not on the 3. So now we'll divide the 3 away. And you are left with x to the 1/3 power equals 5. Now, guys, remember, x to the 1/3 is really the third root of x raised to the first power. It's a radical in disguise. So we're going to raise it to a power to get rid of this exponent. So what power do I want to raise 1/3 to make it cancel out and go away? The reciprocal of 1/3. We're going to raise it to a power of 3/1. And then I'm going to raise this side to a power of 3/1. All right, so guys, when you do this, this is going to become x to the 1/3 times 3/1. Guys, that's going to be 1 times 3 on top is 3. That's going to be 3 times 1 on bottom. It's 3. 3 divided by 3 is 1, which is just x. So these cancel and they go away. That's why we're using the reciprocal. The reciprocal will always cancel that power out. And then it will equal, well, guys, 5 to the 3/1. 3/1 is 3. It's really 5 to the 3rd, which is, if you have your chart handy or your calculator, what's 5 to the 3rd power? What's 5 times itself 3 times? 5 to a power of 3, it's 125. And you're done. X needs to be 125 to make this equation true. All right, so like I said, just like yesterday, we solved for x by raising both sides of the equation to a certain power. We're still doing that as our solving technique, even though there doesn't look like there's a radical, except this time you always have to use that reciprocal power. All right, let's try the next example. I'm going to move mine up. Okay, so now take a look at what that fractional exponent is on. Right now, this power of 2/3 is on this entire piece. So we have to get this whole piece by itself. So the only thing that I have to move away then is this positive 2. So let's move the 2 to the other side. Now you get the quantity, 5x plus 1, all of it is being raised to the 2/3 power. And now it equals 4. Are you sure? Okay. Okay, so now that you have what this rational exponent is on alone, now we can raise it to that reciprocal power to make it go away. So we're going to raise this whole side to the reciprocal power, which is 3/2. But that means you have to raise this side to the power of 3/2. All right, so now on this side, the 2/3 and the 3/2, they cancel, and it just leaves you with the 5x plus 1. And then it's equal to, well, guys, let's take this off to the side. 4 to the 3/2, let's convert that to its power and root. So throw 4 under a radical and make it the square root raised to the 3rd power. So now what is the square root of 4? That's 2. What's 2 to the 3rd power? 2 times 2 times 2? That's 8. So 4 to the 3/2 is 8. And now you're just left with this little tiny equation to solve for x. So hopefully this feels like normal. Let's minus our 1. We get 5x equals 7. Divide both sides by 5. And you end up with a fraction as your answer, which is fine. And you get x equals, it doesn't divide, it doesn't reduce, 7/5. And you're done. Okay? How do you guys feel? Is everybody all right? So we're still raising both sides to a power, except today has to be that reciprocal power. All right, let's keep going. A few more examples, and hopefully we'll feel pretty good about this. Okay, so again, this exponent, this rational exponent, is on this entire piece, x plus 2. So this positive 1 and this negative 1 in front can't be on this side. We've got to get whatever this exponent is on completely alone. So it's minus r1, the one that's not attached. We end up with negative 1, or negative, times x plus 2 raised to the 3/4 equals negative 8 now. All right, keep going. Think of this as a negative 1. It's attached by multiplication, so we'll divide it away. Then you are left with x plus 2 raised to a power of 3/4 equals positive 8. So now we're good to go. All right, okay, so now that we have this by itself, let's raise it to a power that will cancel this exponent out. So we raise it to the reciprocal of 3/4. So now we're going to raise both sides to the power of 4/3. So then you have to raise this side to a power of 4/3. All right, so they cancel, the 3's and the 4's, right? You got 12 over 12, that's 1. So you're just left with x plus 2. And that's going to equal, let's go off to the side, and let's convert this to his radical so we can figure out what number this is. So throw 8 under a radical. It's going to become the 3rd root raised to a power of 4. Go to your chart, look at your 3rd root of 8. It's 2. 2 to the 4th power, 2 times itself 4 times 2 times 2 times 2 times 2 is 16. So we get 16 is what 8 to the 4/3 is. All right, and then all we have to do to get x by itself is minus 2. And now we know x has to be 14 to make this equation true. How are we feeling, okay? Right, just, it's nice because yesterday, whatever root it was, that was the power you raised it to. Today, you're just always raising it to the reciprocal power of whatever is there. But again, the biggest mistake students make is they jump the gun. They raise it to an exponent too early. Don't raise it to an exponent until you have what that exponent is on alone. All right, I think I have 1 or 2 more. Are you okay?
Yeah, right.
What?
There was an ant on my desk.
There's
Only one. It was tiny. It's okay.
There's never just one ant.
I know. We'll blame Mr. Miller. He brought them in.
Yes. All right. I'm going to ask you guys to do this one. You guys try example 4. I'm going to give you guys a head start. You guys solve that one. First thing I did was add that 6 away, and that's all it took to get what that exponent was on by itself. So now I can just raise it to the reciprocal power. So I'm going to raise both sides to a reciprocal power of 2 over 1, which is really just 2. All right? That'll make it 2 over 2, which is 1 over 1, which is 1. They cancel. So now I'm left with 3x plus 1 equals 10 squared, which is 100. And now we're just left, hopefully, with a very simple equation. We'll minus the 1. 3x equals 99. Divide both sides by 3. And x equals 33. Okay? All right. Last one. They throw a little bit of a loophole at us here. where it's like, oh, look, we're back to having a radical, right? Yes, we are. In this last example, you are back to having a radical. However, it is a root and a power that is involved. So you could leave it like this and deal with it in steps. I think the easiest way to approach this problem is to rewrite that back as his fractional exponent. And then I can just raise it to that reciprocal power again. So whether you want to rewrite it now or you want to get it by itself, that's up to you. I'll add the 10 away, try and kill two birds with one stone here. And then as I bring this down, I'm going to rewrite it with a fractional exponent. So guys, look who's under the radical. Under the radical is 3x plus 2, right? So all of that comes out. And now all of that is going to be raised to a power of 4, and it has a root of 3. So rewrite it as its fractional exponent. Power over root is a power of 4 over a root of 3. So you can rewrite that as 3x plus 2 to the 4/3 power. And then it equals 6 plus 10 is 16. So now I have what that rational exponent is on alone, and now I can just raise it to that reciprocal power to get it to go away. So I'll raise both sides to a power of 3/4. They cancel. I'm left with 3x plus 2 equals, well, let's see, what's 16 to the 3/4 power? Throw 16 under a radical. It'll become the 4th root of it, raised to a power of 3. Go to your chart. The 4th root of 16 is 2. 2 to the 3rd power, 2 times 2 times 2 is 8. So that equals 8. And now we're just left with this hopefully very nice equation. So I'll minus my 2. 3x equals 6. Divide both sides by 3. And x equals 2. And we're done. How do we feel, okay? Pretty nice and easy, hopefully, nice and smooth. Any questions at home? Are you guys okay? We're all right? Okay. All right, guys, that's it. That's where I'm going to end with you guys with these types of equations. So I did make a homework assignment for these types of questions. It's 5 multiple choice questions on quizzes. So that should already be on your Google Classroom. That assignment is not due until 11:45 tomorrow night. Yesterday's homework is due tonight at 11:45. So guys, tomorrow, I'm just going to bring you in for a quick Google Meet, make sure everybody did okay on their homework, see if anybody had any questions, and then I'm going to give you tomorrow's class period to either finish this homework on quizzes. If you want to save it for tomorrow's class period, that's fine. And then if anybody has any questions for me, and then Thursday we'll take our quiz. So guys, I'm going to go out on a limb here. I'm going to say you are officially done listening to me for 30 minutes straight, all right? We are done. Congratulations, we have made it. We have seen all of these sections that I needed to get through, so we did it, all right? All right, I'm going to double check the attendance really quick, and then I'll let you guys get out of here.